Hi guys, welcome again to our MPLAB XC8 tutorials for absolute beginner series. This is tutorial 49, temperature logger to SD card with menu control. In this project, we're gonna apply the skills we have learned in the tutorials interfacing an SD card with PIC Microcontroller, the analog to digital converter, the UART and the MPLAB Configurator tutorials to build this mini project to understand how we can use different peripherals of a PIC microcontroller in a single project. This video was sponsored by PCBWay, a Chinese-based PC board prototyping and assembly with great quality at low cost. As with other electronic design contests like Hack Day Prize, this year again PCBWay has launched the third PC board design contest where you stand a chance to win really big. They are offering over $5,000 in total prize and launch your product to market with them. All you need to do is to design your electronic product that uses a PC board and enter the competition and stand a chance to win. This is the timeline. The submission period began 25th of October 2019 and it's gonna end on the 25th of April 2020. So you still have time to submit your project, and here are some of the rules. You'll have to upload your entries in the PCBWay community and enter the keyword third PC board design contest. There is no limit to the design, so you can enter as many projects as you like. And here are the prize. The first winner is gonna win $1,000, including 10,000 PCBWay bins and startup service. Your product is gonna be selected to sell in the PCBWay Bazaar, which is an electronic marketplace. They're gonna be also the category of the most popular design. They're gonna be the second prize and the third prize as well. Here are some of the current entries. You can click on this view more to view the current participant, and to learn more about this contest you can visit this link to learn more. An SD card or SDHC card is a perfect data storage for a temperature logger, as it can store huge amount of data permanently over a long period of time. We have discussed a lot how to interface an SD card with a PIC microcontroller in our previous tutorial, so we're not gonna repeat it again here in this tutorial. In this project, the temperature will be read every 20 seconds and stored in a file on an SD card. Here we are using 20 seconds just so that we can have enough data quickly for a demonstration. But in real life, in many applications, a longer period might be used, like reading every hour or even longer. When the application starts, the user will be given two options, either to save the temperature to SD card or send the temperature data to PC. If the first option is selected, a new file data.txt will be created, or if this file already exists, it will be appended, and the temperature data will be saved every 20 seconds. But if the second option is selected, the temperature reading will be just displayed on the PC. In this project, we're gonna use the PIC 16F18346, a 8-bit PIC microcontroller with analog, core-independent peripherals, communication peripherals, peripheral pin select, which enables pin mapping when using digital peripherals. This adds flexibility to the design, as one peripheral pin can be routed to a different pin. This PIC has 28K of program memory and 2K of RAM. We're gonna use this PIC on the Curiosity development board. We're gonna also use the LM35 as a temperature sensor. We're gonna use a micro SD click board, a serial to USB converter, and 8 gig micro SD HC card. But you could also use different hardware. For more details on the component and breakout board and the Curiosity development board used in this tutorial and where to buy them, please check the links in the description of this video. So let us start a new project. It's gonna be a standalone project. We're gonna use the PIC 16F18346. Next. We're gonna select our hardware tool. We are using the Curiosity. Next, select the compiler. We're gonna use V205. Next, we're gonna name our project Templogger SD card. Select the location where you're gonna store our project. Finish. Open MCC. The package we're using is a deep package. We're gonna start with the system module. We're gonna use the internal 16 MHz oscillator. Divide clock by 1. Watchdog timer is disabled. And we're gonna enable the low voltage programming. This is important as the Curiosity development board works only in low voltage programming mode. The next thing, we're gonna add the FATFS. This is basically the same chain FATFS library, a generic file system module for small embedded systems. To learn more, you could click on this link to visit the home page. It says the FATFS module is written in compliance with NCC C89 and is completely separated from the disk I/O layer. So it can be used with 851, it can be used with PIC microcontrollers, AVR, and so on. Click on configurations. To learn how you can configure this peripheral, you can click on this help button. It's gonna open a new help window. You can read more to learn how you can configure this library. For example, to insert the first physical volume, you just have to click on insert, functionality, optimizations, and so on. So we're gonna insert our first volume. We're just gonna use one volume. Click on insert driver. It's gonna automatically add the SD card foundation library as well. Let's go back to FAT. It inserted the first driver. The label is DRVA. We're just gonna leave it at the default. We're not gonna change it. Here you can optimize your library to disable features that you're not gonna need. We're gonna select this one. We're gonna disable the string functions. We're gonna enable the function that write to the drive, and we're gonna enable the relative path support. The rest of the stuff, you can leave them at their default values. We could also select all file shares one data buffer. This is gonna decrease the RAM that we're gonna use. And that's all. Click on SD card. We only gonna enable the chip select pin. We're not gonna need the card detect and the write protect in this example. Under the foundations, SPI master. Our actual SPI speed is gonna be 400K when we're gonna initialize the SD card, and it's gonna be 2 meg in fast mode. Next, we're gonna add the ADC device. We're gonna use the ADC PIC10, PIC12, PIC16. As with other libraries, you can also click on the help button if you want to learn more how you can configure this library. You can even click on the wiki page. It's gonna take you to an external page where you're gonna get more information and even a sample project how to configure the ADC. So this is gonna take you to Microchip Developer Help website where you can learn more. So in this example, it's quite simple. So we're not gonna need all of this. We're gonna basically enable the ADC. The ADC clock, we're gonna select the FRC. The result alignment, we're gonna align our result. The positive reference is gonna remain VDD and the negative reference is gonna remain VSS. We're not gonna enable the interrupt, and basically that's all. The next peripheral we're gonna need is the UART to print our data to the PC. UART, we're gonna enable the UART, gonna enable the transmit, the baud rate, let us set it to 19200. We're gonna also enable the receive. We're not gonna need the interrupt in this example. and we're not gonna redirect stdio to UART because we're not gonna use the standard fprint function. This is to save some memory of this chip. We're gonna create our own function to print a string to serial output. And lastly, we're gonna configure our pin modules. Okay, we've got already some default pins which have been set by MCC. We're gonna use the analog channel 0. Gonna name our pin LM35ANA0. It's gonna obviously be an analog input pin. The UART RX pin has been set to RB5 and the TX pin has been set to RB7. Let us configure the SPI pins. The clock pin has been set to RB6. The SDI pin has been set to RB4. Now we need to set the SDO pin. So it is not been selected by default. It means it gives us an option to use the peripheral pin selector to route this pin to a different pin which is available. Okay, we've got the chip select pin is connected to RC6. The master out slave in is gonna be RC7. The clock is already on RB6 and the master in slave out is gonna be on RB4. So the SDO pin we're gonna set it to RC7. The SDI to RB4. And the chip select we're gonna set it to RC6. And that's all, guys. Let us generate the code. Generation completed. Let's go to our project. Generated the main C file for us and all the drivers that we need. We've got MCC drivers, everything were generated successfully. So the first thing we're gonna do, we're not gonna need an interrupt, so we can basically delete all this. We're gonna need two variables to select the choices when the application start. This is the function we're gonna use to send a string of character to a PC terminal. We're not gonna use the printf as it requires huge amount of memory. With this PIC with all the peripherals we have selected, we might run out of memory very soon. So when the application starts, we're gonna use this function to send a message to the PC terminal. Temperature logger to SD card, student companion, and after a delay of 2 seconds, we're gonna display the menu to the user. Please select one of the following by tapping 1 or 2. Then on the second line, we're gonna send save temperature to SD card as the first option, and the second option, send the temperature data to PC. Then we're gonna wait in a do while loop to read the character from the PC. We're gonna start flag equals to 0. Then we're gonna stay in this loop while flag is still 0. So the first thing we're gonna read, we're gonna check if the UART receiver is ready to receive a character. Choice equal UART read. Then we're gonna echo back the received data so that we can see our choice on the PC. So if the choice is 1, then we're gonna set the flag and we're gonna send this text to the screen to show the user what they've selected. Option 1 is selected, the temperature will be saved to SD card. And if the user type 2, then we're still gonna set flag and we're gonna send option 2 selected, the temperature will be sent to PC. Then once this flag equals to 1, we're gonna exit the loop. After we have exited the loop, then we're gonna enter our while one loop where our code is gonna loop continuously. So let us write some functions to read the temperature and to save the temperature to SD card. We're gonna call those functions continuously in the while one loop. Okay, we're gonna start with the read temperature function. Void read temperature, we're gonna name our function read temperature. We're gonna define our scale convention, 5 times 100 divided by 1024. The convention from integer to Celsius equivalent as the Vref equals to 5, data comes in as a millivolt value, must be scaled by 100. 1024 is a 10-bit ADC value. We're gonna need two more variables, unsigned int 16 row, and chart temperature. It's gonna be an array. In the read temperature, we're gonna start the convention, ADC start convention LM835. Here we are specifying the analog channel. You can read more how to use these functions from the header files, the adc.h. It's got some defines on and some few examples how you can use these MCC generated functions. This is the function to start the convention. You have to specify the channel, the analog channel that you are converting. Then we're gonna wait while the ADC convention is not done yet. We're gonna wait here until the convention is done. Then we're gonna read the convention result. We're gonna say row, which is a variable, equals to ADC get convention result. Then we're gonna use our convention equation to convert the ADC value to degree Celsius. The LM35 produces 10 millivolt per degree Celsius. We're gonna say volt in equals to row times the convention row temp, which is gonna be 5 times 100 divided by 1024. The next step, we're gonna convert this long to string. We're gonna use the function L to A, which converts a long variable to a string equivalent. We're gonna save it in the temperature string. To be able to use this L to A, we're gonna need the stdlab and the stdio.h libraries. The next thing, we're gonna write a function now to save our temperature to SD card. We're gonna start by defining our work area, FAT/FS drive, and our file object. This is needed for each open file. We're gonna name it file. Then we're gonna write to SD card. This is gonna be our function, void write card. We're gonna name it write card. We're gonna define some few variables that we're gonna use. Assign int actual length, data new line. This is gonna send the carriage retain and the line feed so that we can write to the next line of the text file. Then we're gonna need to write some text temperature is. Then we're gonna check if the SD card is present, otherwise we're gonna return. The first thing, we're gonna mount our drive. Then we're gonna use the fopen to open, append or create the data.txt file. To learn more how to use these FAT/FS functions, you can check their documentation online. They've got a good documentation. You can see fopen. This is the function prototype, and these are the flag fa read. This specifies the read access to the object. We've got fa write, specifies the write access. We are using fa open append, which is the same as fa open always, except the read write pointer is set to the end of the file. And we are also using fa write, specifies the write access to the object. And here they are giving you a simple example how you can use this function. You're gonna need the file object, the text file, which will be created or appended. Here they are opening a file, and the read flag. So in our case, it's gonna be the file object. We're gonna have the data.txt file. If it does not exist, it will be created. If it already exists, it will be appended. And these are the flags that we are using: fa open append or fa write. And these are the return values. You can return fr OK, fr disk error, and so on. In our case, if it returns fr OK, then we're gonna write temperature is. This is the write function. Let's go back to our documentation. This is how we can write to a file. It says we're gonna need pointer to the file structure, pointer to the data to be written, then the number of bytes to write, then the pointer to the variable to return the number of bytes written. So we're gonna have our file object, the temperature. This is our text that we're gonna write, which is gonna be temperature is. Then we're gonna check the number of bytes to write and the pointer to the number of bytes to be written. After that, we're gonna write the actual temperature. This is read from the temperature read function. Then lastly, we're gonna go to the new line by writing the carriage return and the line feed. Then we're gonna close the file object. And that's all, guys. So in the while one loop, we can call these functions. The first thing we're gonna check, if choice equals to 1, we're gonna read the temperature. Then after that, we're gonna write to the SD card. And after a 20-second delay, we're gonna repeat again. And if the choice was 2, then we're just gonna read the temperature and we're gonna send the temperature data to PC. We're not gonna save it. Send string temperature is, then we're gonna send our temperature value, and this is the degree sign. Then we're gonna write the C character for Celsius degrees. Then we're gonna go to the next line, and after 20-second delay, the cycle is gonna repeat itself. And that's all, guys. Let us build our project. The build failed. Let us see what could be the problem. It says undefined symbol L2A. I think this function is not supported in the C99 standard. Let's go to properties. The C standard is C99. Let us set it to C90. Apply. Link in C library, C90 as well. Let us build again. Build successful. Let us plug our curiosity. Let us connect the curiosity development board USB cable as well. Make and program curiosity. Programming verify complete. Let us start our Windows terminal. We are using TerraTerm, but you could also use any Windows terminal of your choice. Gonna select the serial. The COM port is gonna be COM port 4. Okay. Reset the curiosity board. Let us set our serial port. The speed is 19200. That's what we set in the software. Just gonna clean up this, clear the screen and reset again. Okay, now we can see some characters. Temperature logger to SD card. Please select one of the following by tapping 1 or 2. We're gonna start by tapping 2 so that we can send the temperature to PC. 2. Option 2 selected. It says the temperature is 28 degrees. It's not bad, even if we are not considering the decimal portion of the temperature. So every 2 seconds, it's gonna display the temperature. Me just touch our sensor so that I can increase the temperature. Now it's 30 degrees. If we need to go back to this initial menu, we'll have to reset our development board. Let us insert first the SD card. It's an 8 gig. Reset. Now we're gonna select the first option. Set option 1 selected. The temperature will be saved to SD card. It's gonna start a new file and save the temperature reading on this SD card. Just gonna touch the sensor again to increase the temperature. Can maybe bring the ice so that I can try also to decrease the temperature so that you can see how the temperature is fluctuating. Just decrease the temperature. Putting my sensor on the ice. Okay, I hope it's gonna decrease it by a few degrees. Okay. Remove the card. Set on the PC. Let us check our file. Data.txt was created. Okay, this is our file. These are the temperature variations. Okay, the temperature started to decrease when we put the ice on the sensor, then it started to increase again. So basically this is how you can create a simple temperature logger and save your data to SD card. And thank you guys for watching this tutorial. I hope we enjoyed it. If you've got any question, you're welcome to ask your question in the comment section of this video. If you've got some suggestions for future tutorials, you're also welcome. And I'll see you guys in the next tutorial. Thank you.